we present MRUnion, asymmetric task-aware 3D mutual scene generation of dissimilar spaces for mixed reality telepresence. Given two dissimilar spaces. The left is the large room with the local user in blue and the remote user in orange. On the right is the small room with the local user in orange and the remote user in blue. User orange and user blue would like to work on an asymmetric task with different user roles, which requires accessing the full room during collaboration to utilize various resources, including tools, objects, and information. When user blue needs to access a tool on the desk, they would be staring at the wall in user orange's room. User blue might also need to access a tool from the cupboard. In this case, their avatar would disappear from the small room. The same scenario occurs when user blue wants to read a note on the door or requires information written on the whiteboard. This means that interaction can only occur in the green shared intersection area without disturbing the immersive experience. Therefore, accessing resources in the red shaded area by user blue is not possible with conventional intersection methods. To overcome these limitations, we introduce MRUnion. Given the collection of input rooms of the telepresence participants, we generate an asymmetry-aware mutual scene. First, we extract semantic information from the scenes. Next, we apply context-aware spatial matching to initialize the collaborative area. Then, we generate an asymmetry-aware room layout that enables participants to fully utilize their space within the collaborative task. In the last step, we generate asymmetry-aware virtual furniture to communicate spatial limitations among participants. To communicate spatial limitations with other users in dissimilar spaces, we introduce a taxonomy of mutual space visualization. In the application, we have visually distinguished the mutual space to enhance user awareness and understanding of the shared environment, which is accessible to both users in the same way. We highlight inaccessible areas using semi-transparent walls to improve spatial awareness. Synthetic floors, ceilings, and walls indicate to the user in the smaller room the spatial limitations of the combined space. We also show virtual furniture that serves as an intuitive visual cue, indicating to users that the space is occupied by a physical object in one of the remote spaces and should be avoided, thus preventing any potential virtual collisions. In the following, we aim to showcase our method in two real-world dissimilar spaces, one large space and one smaller space, which is approximately half the size of the larger space. In the intersect method, collaboration is performed in the intersection area of both rooms. The large room, shown on the left, includes an augmented synthetic wall, which corresponds with the intersection boundary, allowing for a better comparison between the union and intersect methods. On the right, the smaller room has no synthetic walls, as it is entirely within the intersection area. The user in the large room cannot access resources beyond the synthetic walls. Otherwise, their avatar would disappear behind the physical walls for the user in the smaller room, disrupting the immersive experience. Thus, with this method, a significant portion of the large space becomes inaccessible for collaboration. In the union method, collaboration takes place within the union of both rooms. For the user in the large room on the left, no synthetic walls, ceiling, or floor are present, as its boundaries define those of the union space. On the right, the smaller room is virtually extended, with 3 of its 4 walls removed to allow the extension. In the union layout, both users can fully utilize their rooms and access all resources. The user in the smaller room can also observe the movements and interactions of the user in the larger room outside the intersection area. We evaluated our method on 882 scene combinations involving 2, 3, and 4 combined remote spaces and compared it to a conventional intersect room layout. For the quantitative evaluation, we used 2 metrics. First, we measured the resulting room size, which is the area accessible to the user in their room. Second, we measured the total number of interactable objects. The results showed that the resulting room size for the union method was significantly larger than the original room size, while the intersect method resulted in significantly smaller sizes than the original room. For the union method, all interactable objects from the original rooms remained present in the shared space. This was not the case for the intersect method, where we found significantly fewer objects in the shared space. Our exploratory user study aims to evaluate our method for asymmetry-aware scene generation in a real MR telepresence scenario. We are interested in analyzing how the union room layout compares to the intersect layout with respect to user experience, and whether there are differences between the modes, MR and VR. This results in 4 conditions, which we evaluate in an asymmetric collaborative assembly task setup. The study involves 2 users, an operator in a large room and an instructor in a small room. They collect and assemble bricks based on an assembly plan. In the intersect conditions, the collaborative assembly task is confined to the intersection area, while in the union conditions, resources are distributed throughout the entire room. Consequently, in the union layout, interaction with areas beyond the intersection space is required to access additional information. For spatial presence, we found equivalence between the 2 layouts. Additionally, VR resulted in significantly higher ratings. For social presence, we identified significant main effects for both the layout and the mode of mediation, with VR and intersect leading to higher scores. Neither the mode of mediation nor the layout had any significant effect on perceived workload. While there was a significant interaction effect between these 2 factors, post hoc tests did not reveal any significant differences. Regarding preferences, users reported a significantly higher sense of safety and support for the collaborative task in the intersect layout. Users significantly preferred MR over VR in the general feedback category, as well as for safety and comfort. Based on our analysis, we propose specific design implications for synthetic mutual spaces in asymmetric task-based MR telepresence scenarios. We recommend using the union layout for collaborative asymmetric tasks that require full room access. Additionally, we suggest allowing users to dynamically adjust the room layout based on their preferences and activities within an MR telepresence scenario. Finally, we propose visualizing spatial limitations to enhance user awareness and interaction.